Lambdas of S is the spin diffusion length of this wire. A is the cross section, and L is the distance between these contacts. And so the first thought was, well, we looked at this and said, wow, the silver must have oxidized or tarnished or something, and the resistivity went up, and that's why the signal went up. You know? And so the sample is no good anymore. But that is not what happened, because when we measure the resistance versus temperature, first of the original silver wire, later of the silver wire after it had been 2 weeks in air, there is a small increase, but it's only like 10%, not so much. So if it's not the resistivity, it's probably also not the spin diffusion length, because the two are inversely proportional to each other. And in any case, we would expect that the spin diffusion length only becomes shorter, and that will make the signal smaller. So it was clear that this injection polarization had to increase quite a bit. And so how do we figure this out? Well, we figured we'll just cut these devices. And so we use the focused ion beam to make small slices, not of the exact device, but similar devices. And we looked in transmission electron microscopy, how it looked like. And so here what you see is, you see this permalloy wire covered by the silver wire. So the permalloy wire goes in and out, of the screen like this. And here you see a distribution of the oxygen measured with electron energy loss spectroscopy. And so nothing funny, here's permalloy silver, there's maybe some oxygen in the silver, but nothing dramatic. Now when we took a sample that had been 2 weeks in air, we saw that there's now an additional layer between the permalloy and the silver. And if you look here, it's an oxide because it mostly consists of oxygen, or there's definitely quite a bit of oxygen there. And this is kind of surprising because this interface is underneath all the silver film, right? So we didn't expect that after we made the device that at the interface something would happen, certainly not within a couple of days. But then if you go back and look at some old literature, you see that oxygen can diffuse very readily through silver. And so within a couple of days, you do form an oxide layer here. And this turns out to increase the resistance at the interface, and it gives much better spin injection efficiency. Why is that? If you have a spin in the permalloy and you inject it into the silver, thereafter there's essentially two things that can happen. The spin in the silver can stay in the silver, diffuse away and relax somewhere there, or it can get reabsorbed in the permalloy. Now, spin lifetimes in permalloy are much shorter than in silver. And so the spins diffusing back into the permalloy is actually the preferred mechanism of relaxing the spins. But